Hi, how you doing, guys? I just wanted to go over the first example in 3.2 in the workbook for 3.2. First of all, just going over the key points right here. Obviously, the main point in 3.2 is the least square regression line. This is important for you to read over. I'm just going to go over the main points, though. When a scatter plot suggests a linear relationship between quantitative, explanatory, and response variables, we can summarize the pattern by fitting a line to the points. This line can be used to predict values of the response variable for a given value of the explanatory variable. All right, so we can make a prediction, and that's by the least square regression line. Be careful, we should be cautious of making predictions when it's far outside of the X values. If you have a bunch of car prices that are in like the 20, 30,000 range, and you want to make a prediction for, some type of prediction, maybe, I don't know what it is, gas mileage, whatever, how long it's going to last, for a car that is $200,000 or $300,000, that would be an extrapolation. Or if you want to make it the other way, if you want to make a prediction for a car that's maybe just worth $1,000, maybe it's a really old car, that would also be an extrapolation, all right? Something that is, if your X value is way outside of your actual observed values, then we call that extrapolation. The equation of a least square regression line can be calculated by hand. However, it's better to use a calculator. It's good to understand, though, how the standard deviation and the correlation are calculated. Right here, the y-intercept is often meaningless in the context of our situation. I don't totally agree with that. Sometimes for that car example, for example, right here, remember, miles was your X value. So, if, let's say, miles driven is 0, that means it's a brand new car. All right, so sometimes it's useful, maybe sometimes it's not. The slope is a key value of interest in describing the relationship between the two quantitative variables. It tells us how much the predicted value of y increases for each 1 unit of X value. All right, just thinking about that Ford F-150 example, for every mile driven, it showed us the price variation. Put that in your long-term memory bank because you can see it in future chapters. By the end of this section, you should be able to construct and interpret a least square regression model, justify its use, and use it to make predictions. Be sure to focus on interpreting the different components of the model. Concept 2, a regression line is a line that models the data. That is, it summarizes the overall pattern and provides an equation that represents the relationship between our explanatory and response variable. This equation can be used to predict the response for a given value of an explanatory variable. Use caution not to extrapolate. We just talked about that, making predictions way outside of the X values, the observed value of the observed X values. Concept 3. Chances are any scatter plot you construct or encounter will not display a perfectly straight line. In most cases, the observed points will be well scattered. That's the whole point, okay? Because most of our observed relationships are not perfectly linear, predictions for y made for our regression line will often be different than observed y values, resulting in a prediction error. So we call those prediction errors residuals. That is, there will be some amount of vertical distance between the regression line and the observed value. Those are residuals, right? Remember what we were talking about. We have right here our scatter plot, right? So they end up making a regression line. Right here, this is the predicted value right here. This is the actual value. And a residual is just going to be, sorry, it's not totally straight, but the residual is going to be the actual minus the predicted, AP. Just remember that, actual minus predicted. All right, the regression line that best fits our observed data is one that minimizes the squared residual. Remember, I told you the reason that we square the residual is that so they're all positive. And the best regression line is one that has the smallest squared residuals. This is essentially what's a least square regression line, but you used to know this back in the day as a line of best fit. So our line of best fit is now called a least square regression line. It minimizes the prediction error. All right, that prediction error is like the residual. familiarize yourself with the formulas that you can use to determine the slope and the y-intercept of the least square regression line. We will get to that later. We haven't actually gotten to that yet. We will rely on technology to generate the equation, but you should recognize that we can construct the equation by hand given the mean and standard deviation of x and y, as well as correlation r between them. Okay, let's take a look here. Now to the example. Use the following data to determine the least square regression line to predict exam scores from anxiety scores. Note, higher anxiety scores indicate higher levels of test anxiety. Okay, so it's already giving us what's happening right here. So right here, we're determining the least square regression line to predict exam scores from anxiety scores. So we know that first of all, the anxiety scores we already said is the X is the explanatory variable. Sorry about these colors right here. Let's try this. And the exam scores are Y right here, and that is our response variable. Okay. What is the equation of the least square regression line? Okay, so best way to do this, let's go and just put this into the calculator. So here's what we're going to do. Turn it on, wait for it to turn on, get out of here, and we go to stat right here, and we go to edit, right? And we get rid of what is already there, clear, enter. And right here, we're gonna say clear, enter. Oh, sorry, go up to the top, clear, enter. Okay, so let's go and put all this good stuff in there. All right, so we have right here for anxiety, that is my X, and that's going to be like my L1 right here. So let's do it. So first we have 23, 14, 14, 0, 7, 20, 20 again, 15, 21, and 4. And make sure it's easy to make errors on this virtual calculator, but I think it's okay. All right, just make sure that's all right. Yeah, it looks good. All right, now let's go to Y, which is going to be our exam score, and that's going to be put in L2. So let's do it. We have 43, 59, 48, 77, 50, 52, 46, 60, 51, and 70. All right, very good. Just again, make sure everything's lined up and that you put everything in correctly. I think it looks pretty good yep, looks good. All right, awesome. So we're gonna find what's the least square regression line. So remember what we do from here. We press stat. We go over to calc. Okay, and we go to Lin Reg, but 4 is going to give us like our typical y equals mx plus b formula. We want it in like, the kind of the statistical format. So we actually go down to the 8th one right there, Lin Regression a plus bx. Okay, there we go. All right, x list is L1, y list is L2. All right, make sure you don't have like previous entries here for like resid. Make sure it just says L1, L2. Remember, if you have to re-put that, L1 is right there. Just press second and get the L1, L2 is right there. Okay? Okay, and if you want to, remember I told you store regression equation. That will just put it right there in my y equals if we're ever going to graph. So if you want to do that, you just go to vars. You go to y vars. You press enter under function and just press enter for y1. That's going to store the regression equation I1. All right, so there we have it. So let's see, the regression equation is y equals 71.346, rounded, minus 1.141, okay? So again, we have right here, the least square regression line, we're gonna say y hat equals, remember, it's a prediction, of course. And just rounded right here, we have 71.346 minus, and the slope was what? 1.141 times x right here. Now right here, also when you write this, they didn't say to put this, but you should actually put just mention what is y hat and what is x. So we'll just say right here, where y hat is the predicted exam score okay, and where x is just going to equal your anxiety score, student's anxiety score. Actually, I don't know if it's a student's, that's right. So let's just put anxiety score. If it's not specific in the instructions, then just keep it non-specific in your answers too. Okay, interpret the slope of the least square regression line. Okay, so let's go ahead and do that. We're going to go and interpret right now the slope of the least square regression line. All right, so let's get it. First of all, my slope is right here. And remember, this is in the form y hat equals b sub 0 plus b sub 1 x. Okay, so in this case right here, my slope is b sub 1. In this case, it is negative 1.141. So what is that saying? If you ever forget how to interpret the slope, think of just classic. Your slope in general is just going to be right here. Remember, your rise over your run. So in my particular case, it is negative 1.141 over 1. Okay. So that means that, and more specifically, rise over run, what is, remember, it's your change in y over your change in x. So you start with the change in x right here. And x is the anxiety score. So we're going to say right here, for every 1, and in this case right here, we're talking about, you can say 1 unit or 1 point. I'll say 1 unit increase in my x, which is anxiety score. So for every 1 unit increase in the student's anxiety scores, there is a negative 1.141, or actually, instead of saying negative 1.141, we'll say a 1.141 decrease in the student's exam scores. Okay, something about like that. All right. The book says for each increase of 1 unit in anxiety scores, we predicted exam score decrease by about 1.14 points. So right here, and then this is something that I sometimes forget right here. So one thing, very important thing, I didn't need to say students, by the way, but what did I forget to say? Remember, y hat is a prediction. So there is a predicted 1.141 decrease in the student's exam scores. Don't forget that. You will actually be taken off if you did what I just did right there. Make sure you say predicted 1.14 decrease in the exam scores. Okay, you don't need to say students. Okay, so sorry about that. Okay. All right, don't give more information than you need to. 3. What exam score can we predict for an anxiety score of 15? Okay, so no problem. So we have right here our anxiety score, which our x is 15. So right here, let's go back. Our equation is y hat equals, where was it? 71.346 minus 1.141x. Okay. So we have an x is 15. So what exam score we can predict right here? So no problem. Just make sure. I know this is easy, but do show your work where you're plugging in. I know it's annoying, but we're just plugging in 15 right here. And then you calculate, if you go ahead and calculate this on, it should be approximately 54.2, it looks like, okay? Something about like that. So right here, you have y hat equals 54.2. Okay, so just make a, so what exam score can we predict for anxiety score of 15? We can predict an exam score of 54.2 for an anxiety score of 15. Okay, something about like that. Let's go to number 4. What is the residual for anxiety score of 15? All right, so remember, residual. That's going to equal your actual minus predicted. I know it sounds kind of stupid or whatever, but just think AP. We're in an AP class. That's what the formula is for residual. Actual minus predicted. All right, so more specifically right here, if we're using our actual terminology, actual is going to be my real Y, and predicted is going to be Y hat, okay? And we're trying to find this for specifically an anxiety score of 15. Okay, so no problem. So let's get what we need to do is get our actual Y value for X equals 15. And remember, Y is right here, exam score. So let's get our actual exam score for X equals 15. Okay, so let's look at the original data here. There we go. 15 comma 60. So there we go. So that means Y equals 60. So this is our actual. Okay. Now, secondly, now we need to get our predicted exam score. I'm just going to go over here for X equals 15. All right, so we're going to use our, right here, least square regression line equation. So Y hat equals 71.346 minus 1.141 times 15. And we realize, oh, wait a second, we just did that. There it is right there, 54.2. Okay, so we have right there, that's going to end up being 5.8. Now, this did not say to interpret, but if we did actually work on interpret, it's actually pretty easy. We can see right here the difference in the actual exam score and the predicted exam score of a student who has an anxiety score of 15 is 5.8 points. Simple as that. Now, it didn't say to interpret it, but if it is, it's pretty easy. You can just look at the equation and do it, right? All right, number 5. Should you use the least square regression line to predict an exam score for a person who has an anxiety score of 35, why or why not? Okay, let's see. What we want to do is look at our original data right here, and we see that our lowest score, our minimum, looks like our minimum right here was 0 for anxiety score. Minimum was 0. And it looks like our max right here is 23. So you tell me right here, they're saying right here, should we use this for 35, for X equals 35? Okay, I'm going to say no. Okay, that would be an extrapolation right there because that is actually way, way, way far out of our actual data values that we have here. The highest data value we have right here is 23. So specifically right here, we'll just say no. 35 right here is greater than the maximum observed anxiety score. Okay, so right here, And we could just say right here, using the least square regression line, I'm just going to put LSRL to predict an exam score for someone with this anxiety score represents extrapolation. All right, but really, if you're just, so that's right here, why or why not, right here. Using the least square regression line to predict an exam score for someone with this anxiety represents extrapolation. But really, we kind of answered it right there because we said 35 is far greater than it is, actually, I should have just said right here, it's far greater than the maximum observed anxiety score. So if we're using, that represents extrapolation for actually using values way to the right or way to the left of our general X values. Okay? And so that is it for the first example. All right, guys, hope you learned something here.